C'est quoi?
C'est le courant qu'elle a commandé.
Morning everybody, and welcome to the third in our series of webinars, and this one is on the topic of deactivated yeast. If you missed our previous webinars on sourdough and success and bread improver technology, you'll be able to catch up with these on the Lesaffre YouTube channel, where this webinar will also be posted after today, and the link will be appearing at the end of this presentation. Now though, I'd just like to introduce our speakers for today. My name is Sara Autton, and I'm Technical Manager for Lesaffre UK and Ireland. And as part of the team here in the UK, my role includes giving technical advice and support to our customers in their daily production. This can encompass raw material selection and recipe development, process optimization, and on-site and off-site training, amongst other things. And as part of the wider Lesaffre team of bakery experts, I'm also able to call on the experience of colleagues from other countries. And today, my fellow presenter is Thibaut Rennard. And Thibaut is in charge of coordinating the Lesaffre Group commercial and marketing activities for bread improvers, mixes and blends. He works closely with the Lesaffre Research and Development Department, the Lesaffre regional teams and suppliers to develop improver formulations that are adapted to the needs of local markets. And Thibaut's experience of activated yeast usage has been on both the technical and commercial fronts in fully automated industrial bakeries and flour millers in Spain and France, Turkey and the Benelux countries. He's variously used deactivated yeast for laminated croissant dough production, for baguette production and industrial pizza production, as well as as a flour corrector, which we'll hear about later on. Welcome to you, Thibaut, and thank you for joining us today.
Thank you, Sara.
Welcome. I must also thank Autton for putting together all of the technical bits and pieces that allow us to present to you today, and for coordinating the invitations and invigilating our surveys that we'll be asking you to take part on during the course of this webinar. There'll be a question and answer session at the end, so please don't hesitate to write your questions in the chat bar at the right-hand side of your screen as we go along. But when you do so, please make sure at the bottom of the screen there, you hit the moderators only button in the blue bar there just to make sure that we actually see your questions. Okay, so don't hesitate to do that, please. So without further ado, Thibaut, I'm handing over to you to tell us all about deactivated yeast and its effects on the rheology of dough. Thank you, Thibaut.
Thank you, Sara. Thank you very much. Hello, everybody. Thank you again for the introduction. We will start this webinar presentation with a little introduction on deactivated yeast. So at first, what you have to understand is what is deactivated yeast. Deactivated yeast is at the beginning is like another kind of yeast, is a microorganism which will produce an higher content of a particular amino acid molecule called glutathione. Okay, this to produce this deactivated yeast, we begin with a standard fermentation, just like any other production, and then we will kill the yeast with an autolysis and dry the what is deactivated liquid yeast. We will dry it up and pack it for expedition. So as you can see, the production here is on the bottom of the slide. Okay, the deactivated yeast is a yeast with no gassing power. Okay, it's not like the yeast you will use to proof the bread. It's not producing any CO2. Okay, the idea with deactivated yeast is to use the glutathione that the yeast have been producing during the fermentation. What is a glutathione? So as we explained before, we have a yeast that will produce lots of glutathione that we will inactivate, but we will keep this molecule here, which has a particular functionality. It's a reducing agent. A reducing agent has the ability to reduce the tenacity of the dough. It will act on the gluten network of the dough, and it will break molecular links, which are called disulfide bonds on the gluten network. And by breaking those molecular links, it will help the dough having a more extensibility and less tenacity. What is so a reducing agent? To characterize a reducing agent like a glutathione and deactivated yeast, there are other reducing agents like we will see after. We use the NRP. The NRP is the natural reducing power. The natural reducing power definition in industrial production is the equivalent in ppm, in part per million of monochloride rates of L-cysteine contributed by 1% of dry matter of deactivated yeast on flour. So the NRP is measured by a iodometric method. Okay, it's a chemical measurement. And it's based on the oxidation of the yeast reducing substance. So mainly, like we mentioned before, the sulfhydryl bonds that affects the gluten network. Okay, so the idea here is that we can characterize a reducing agent by the natural reducing power. It's a chemical measure. And we have different kind of NRP depending on the type of deactivated yeast that you have. Okay. So in other words, a deactivated yeast with an NRP of 100 use 1%. Use at 1% will have the same reducing effect of 100 ppm of cysteine. Here you have a comparison of the natural reducing power, the NRP, and the gassing power of different kind of yeast. First one is the compressed yeast here. Compressed yeast, 30% dry matter, so it's the classic compressed yeast that we find almost everywhere in Europe. So as you can see, the gassing power usually is around 130 milliliters of CO2 per 2 hours. And you have a natural reducing power of around 35. The thing is, the natural reducing power available in the dough is 0. Why is it 0? Because when in the yeast cell, the reducing agents are inside the yeast cell. The yeast is not dead, so it's it will not let the reducing agents go and affect the gluten network. So you have reducing power inside the yeast, but it cannot affect the gluten network. So it has almost no reducing effect. On the contrary, with deactivated yeast, here you have two kinds of deactivated yeast, what is called the Baker's Bonus RS190 and the Baker's Bonus RS190 star. Those two kinds of deactivated yeast don't have any gassing power. You can see here that the gassing power is 0, and the natural reducing power, because they are produced with an optimized process, and they are optimized yeast strains to produce the maximum amount of reducing agents, glutathione. So as you can see here, you can have a natural reducing power of 100 or 200, depending on the kind of yeast, of deactivated yeast that you use. And all the natural reducing power is available to act on the gluten network, okay? Because the yeast cells are killed and open, and the glutathione can act on the gluten network. So what does it do on the dough? Here you have a little drawing of what I explained before. When you create a gluten network, like you can see on the nice picture here, it's a very nice developed dough. What you can, what is going to do the glutathione? It will break here the molecular link, the disulfide bound on the gluten network. So as a consequence, as you can see, you will have a structure which is not that rigid. The gluten structure will be able to slide one molecule with the other, and in the end, you will have a better extensibility of the dough. Okay, here you have a few comparisons with different kind of reducing agents that can be used. The first one is the L-cysteine. Okay, you can see the level of use is 5 to 30 ppm. The big advantage, it is very inexpensive. It's about 0.02 euro per 100 kg of flour. But the problem is very concentrated. It's not clean label. It's E920, and the source for the production of L-cysteine can be a bit controversial, like duck feather and bacteria, or it can be synthetic. Then you have the sodium metabisulfites, which are also pretty common reducing agents. It's the same kind of level of use in comparison with cysteine. It's also very inexpensive, but there are legal restrictions. It's not clean label, and it doesn't have a very good image. Okay, and it's mostly used for biscuits and cracker production. It's very, very strong reducing agents, the metallisulfides. Here you have our deactivated yeast. So the dosage will be between 0.05 and 0.3%. It can go up to 1% for some application. That's be very, very special. The big advantage it has clean label. It should be labeled as deactivated yeast. And the only disadvantage of this product is that it can be a bit more expensive than other kind of reducing agents. Okay, then the last one, you have the protease. Protease is an option. Okay, protease will have the same kind of effect as deactivated yeast, but it will not cut the gluten molecule at the same place. It will be much more aggressive. It will cut at different places. It will also make the dough more extensible. But as you know, the enzymes, they will keep on working when they are at the right temperature and in the right condition. They will, and when they start to work, they will keep on working until you deactivate it. You deactivate the enzyme with the baking step. So if you use a scrap dough, or if you have some breaks in the line and things like that, then it can be problematic. Okay, it's also clean label, as you know, because enzyme don't need to be declared on the label. So during the process for any kind of dough, you have different advantages of deactivated yeast. We will see all the different steps of the baking process. So first is the reduction of mixing time and dough temperature. Here on the picture, you can see a dough without deactivated yeast and with 0.15% of deactivated yeast. So as you can see, you have a smoother aspect of the dough. The dough development is better than the dough without deactivated yeast. And the advantage, as you develop the dough quicker, you can reduce the mixing time. And when you reduce the mixing time, you can reduce the dough temperature also. Okay, so it's a commonly used product for particularly strong flour when it's hard to develop the dough. It's recommended to use some reducing agent to improve the mixing step. Okay, here you have an example of another example of a dough without and with RS190, Baker's Bonus RS190. Okay, as you can see, you can roughly decrease the mixing time of 20%. Okay, going from 10 minutes mixing to only 8 minutes mixing. So you will limit the dough oxidation. Okay, so you will keep some better aromas and flavors of the natural flavors of the dough. You will reduce the dough temperature, which is very important for frozen dough process, for instance. And you can enable the switch from sponge and dough to direct process. Okay, yeah, because when you switch from sponge and dough to direct process, sometimes you can face a few problems of the development, and this deactivated yeast can help. Okay, so as keep in mind that a shorter mixing time can save energy and capital investment and fewer mixer, like we will see on this slide for productivity improvement. So here what we did is a little example of the productivity improvement that you can expect with the activated yeast. Okay, when we took an example of mixing time of 4 minutes slow and 8 minutes fast speed. Okay, when you use the activated yeast, you can reduce the mixing time by something like 20%. which means a reduction of 1 minute 30 seconds with a final mixing time, a new mixing time of 4 minutes and 6 minutes 30 seconds. So before you were producing 5 mixers per hour and roughly 120 mixers per day. And if you use the activated yeast, you can reduce your mixing time, and you can do 5.8 mixer per hour, which would mean 139 mixer per day. Okay, so it's productivity improvement of almost 16%. This is when of course, when the bottleneck is your mixing step. Effects on resting, scaling, and relaxing. So after the mixing, you will have the bulk fermentation. There, the activated yeast will limit the strengthening of the dough. The dough will go through automatic divider without the problem. Okay, it will be more easy to pass on automatic divider. For the dividing and scaling, it will enable a more consistent scaling and weight of the dough. The dough pieces will be more regular and with a better weight regularity. Also for the rounding, when you reduce the tension of the dough and the tenacity of the dough, you will have less tearing during the rounding process, and you will also reduce the relaxing time before shaping. Okay, because you will reduce all the relaxing time in general, because you will have a less strong dough. For the shaping now, when you reduce elasticity, you reduce resistance to shaping. Can be automatic or manual molding. So you will improve the shaping consistency and regularity. You will reduce the resting time for laminating dough, and you will reduce the dough tearing and shrinkage for all kind of dough. Dough pieces are lengthened also more easily. So here you have 2 peaks of an industrial croissant line and a baguette line. So I personally tested this kind of product on that kind of line, and it provides great benefits. Here you have a little quick reminder, just to make sure everybody is on the same page regarding the vocabulary. Okay, is the difference between elasticity and extensibility. The deactivated yeast will increase the extensibility, so it will be easier to make a longer piece of dough. With a small piece of dough, you can make a longer piece of dough. It will be easier. The elasticity, on the contrary, is when you take the dough, when it comes back, when it shrinks back to its first position. So in this case, the elasticity will be reduced. Okay, increase extensibility and reduce the elasticity. Sometimes people get confused with the word. Final proofing now. So better extensibility. You will optimize the proofing with less resistance to gas pressure. So the dough volume, the volume of the bread will increase nicely, and you can reach a greater volume also. And during the baking, same thing. During the baking step, the oven spring will be easier because you will have less resistance to the development of the dough. And that's it.
Thank you very much, Thibaut. Deactivated yeast does appear to be an extraordinary ingredient and very useful. But just before we go on to the next section, where I'm going to talk a bit about the applications, we'd like you to take part in this little survey. So the question we're asking is, what are the common causes of product rejects in your process. And there are 4 possible answers there, but you may select one or as many of those as you like. So I'll give you a little minute to vote, and we'll see what people think. So click away, and we'll see what we get. Everybody had a chance to vote. And there we have it, final product misshapes. That's very interesting because, as you will have seen from what Thibaut's been saying, we can help to reduce final product misshapes by improving the condition of the dough that we're using by using some deactivated yeast. So we get a better shaping and dough rheology through our process. So that's very interesting. Thank you very much indeed for that. So we've heard then from Thibaut that deactivated yeast can have some very useful effects on dough paste or pastry that influence its rheological behaviour. And this can be very useful not only for mechanical processing, but also for hand production methods, as we shall see. So, for example, improved dough extensibility makes the process of hand moulding a baguette, for example, much more simple. For anybody who's not done this before, achieving an even and consistent tension along the long shape of a baguette can be quite a challenge, particularly on an industrial line where the dividing of the dough piece may include a first rounding step, so you end up with a ball shape that you have to then extend into the long shape of a baguette. And if the characteristics of the gluten in the flour are particularly elastic, this can be a problem. So getting the even tension along the length of the baguette is a key contributor to the most successful evenness of the burst on the crust to get the characteristic ears on the finished crust. So dough consistency at this point is very important. And this is even more so when baguettes are being moulded mechanically, because when dough is being hand moulded, of course, the baker can adjust his hand moulding technique according to the elasticity and condition of the dough he's handling, whereas machinery relies on a consistent dough rheology from batch to batch in order to maintain the quality of the moulding that the machine can achieve. So using deactivated yeast can help to even out the variations in dough consistency between batches, which ensures that you get a smooth passage of the dough through the automated moulders, and you get dough pieces at the ends that are of the right length, as you can see here, where we've got an uneven shapes here. With some deactivated yeast, we get dough pieces that are right length, they're all the same, and particularly on a big line like this, that can be very important. You can see from this slide, for example, the differences we get. So without the deactivated yeast, we're getting products that are not the same length. The shaping is quite uneven. We're getting quite uneven opening of the burst, so the ears quite uneven on the burst here. Whereas with some deactivated yeast, we've got a much more consistent length. The shape is much more consistent, and the cuts are much more attractive. So in this instance, the deactivated yeast has certainly helped to improve the finished quality of the baguette. The same properties of rheological modification are also invaluable in all different types of pizza production, for example. For sheet and cut pizza lines, deactivated yeast can remove the linear stress that's put into the dough through the pinning process, which means that here, for example, where the linear stress has been put into the dough this way, when the round shape has been cut out, it's shrunk back. So we've ended up with an oval instead of a round. Whereas with the deactivated yeast, we've lost this linear stress here. So we've ended up with a round shape. And because we've got a more extensible dough, which is easier to deform, if you like, in this instance, we're less likely to get a shrink back if we're trying to get a dough piece that fits a pan completely. So without the deactivated yeast, as you can see, we've got less extensibility. So we've got a less successful shaping for this application. In terms of hand moulding, or slapping, if you like, the manual stretching of pizza dough balls, for example, it can help to reduce not only the time that it takes to get the dough ball stretched out to the right diameter. It can also, because we've got a more extensible dough, you're less likely to get a tearing, so you're not going to get holes in the dough pieces, which can make a very sticky mess on the oven bottom when the pizza is being baked. In this instance, we are looking at pizza that's been produced by a hot press production. So in this instance, we've got a ball that has been passed underneath a hot press. So the time taken for the dough to be stretched out from a ball to the disc is very, very short. And without deactivated yeast, we can get some quite severe shrink back in this particular instance. Whereas with the deactivated yeast, as you can see, we get a much more successful shaping under a pneumatic die. Furthermore, the dough piece will retain its shape while it's being baked. Of course, pizza dough is made with yeast, but deactivated yeast can be used for a similar function in the production of flatbreads, for example, tortilla. This is an example of tortilla production without yeast. So here we have a tortilla that needs to have a certain diameter, a certain thickness, and in this instance, without any kind of deactivated yeast, we're not getting the diameter that we're looking for. But by adding different levels of deactivated yeast, we're getting a much more successful pinning out of the product. Laminated doughs are greatly improved by the addition of deactivated yeast because the enhanced extensibility of the dough means that the laminations themselves are formed more easily and are less likely to tear. And of course, torn laminations is a very common problem, as you can see here. It causes a collapse of the lamination in the finished product. So you end up with a product which is much tougher to eat, more like a biscuit than a pastry, less flaky and less tender eating. And as we've said before, similarly with the production of the pizza, if you're producing, for example, are pie lids. If you're producing a pie lid on a sheet cut line, you want to get rid of this linear stress, as I mentioned before, or in this case, the linear stress is that way, so that when the pastry lid is cut and baked, we're not ending up with we're keeping the nice oval shape, round shape, I should say, rather than the oval. So not only are we getting a more flaky and tender eating crumb structure, we're getting a more successful sealing of our pie because the lid is not shrinking. In the case of large-scale croissant production, you've seen this picture before, Thibaut showed it to you. One further cause of dough elasticity is the low temperature at which these products are made. And this low temperature needs to be maintained to keep the laminating fat sufficiently firm to maintain the layers through all of this pinning, sheeting, cutting and rolling process. Also, the low temperature helps to prevent excessive or even any yeast fermentation before the products are rolled up and they actually get onto a tray and into a prover. So the reduction in mixing time that's afforded by deactivated yeast can help to control the dough temperature, but it really comes into its own when it's on an automated line like this, because it reduces the dough's resistance to being sheeted and cut. And then when it comes to the curling, it again, much like we had with the baguette earlier, you get a nice even tension across the curl of the croissant so that when it goes into the prover and it's baked, you get a nice even control of the expansion of the product in the prover. You get a much more regular shape of the product at the end. So whether the dough in question is a croissant or a pie lid or even a cream horn, adding deactivated yeast can help to preserve its shape during processing and also to increase its delicious flakiness. One of the most useful attributes of deactivated yeast is its ability to improve the pan flow of dough. And this can be very important for products that have a distinctive shape as part of their characteristic. We've got an example here of hamburger buns, for example. We want a hamburger bun to flow into the indented pan in which it's baked in order to give a nice regular shape, as you can see here, and a nice regular rise. So adding deactivated yeast can help to reduce the resistance of the dough and increase its flow so that it fits nicely, it flows nicely into the entire shape of the pan. You can see here that this one is too elastic, and we've ended up with a nice white ring around the outside, which is more often than not a cause for a reject. So by the time the bun gets to this stage, of course, you can't rework the dough. So this is a complete loss in terms of profitability. So as you can see here, there are other possible causes for white rings, but adding deactivated yeast can solve quite a number of these. Other products that we can use deactivated yeast in are those that are baked in a totally enclosed tin or a pan, where the final characteristics of the product rely on the dough completely filling the pan to create this particular shape. As you can see here, the example here is with a sandwich loaf with a lid, where we want nice sharp edges, nice regular shape to the loaf, so we get a nice regular shape to the slice, which is important for sandwich manufacturers, of course, where they want a particular shape and size to the slice that will fit into their packaging. And another example is something like an English muffin, where the product is proved in an enclosed pan, and it's important that the dough piece completely fills the pan in order to create the characteristic shape and structure of a muffin. There are other applications for deactivated yeast, for example, that can ultimately benefit the home baker. So those that are sold in retailers often contain deactivated yeast, which helps to ensure that the products will be easy for the home baker to shape or to help them rise properly when they're baked. For example, this we've got here is a pre-rolled piece of dough. I think this is without... I think this is a pastry. Yes, this is feuilleté, so that's puff pastry. Puff pastry and pre-rolled pizza doughs very often contain deactivated yeast, which help to ensure that the home baker has a successful bake in their domestic oven. And another application is for biscuits. Deactivated yeast is often used in these kinds of products where, again, you want to create a nice even shape so that they fit into the package nicely, but also a nice tender eating product. Remember, I mentioned before when we were using deactivated yeast in a laminated pastry, it helped create the laminations and to preserve the integrity of the laminations. Well, in much the same way, the deactivated yeast, it reduces the resistance of the dough to rising, you end up with a more tender eating crunch and bite to a product such as a grissini like this. And it can it's often used also in biscuit manufacture, where the biscuit dough might be a very lean recipe. A lot of biscuits, of course, contain fat and sugar, which help to reduce stresses on dough that's sheeted and cut. But for leaner recipes, like crackers, for example, or doughs that are made from biscuits that are made from very thin sheets of dough, the benefits of deactivated yeast, as we've mentioned before, is that we get a much more successful production run, and also it's much easier to use and more efficient to use the trimmings that have deactivated yeast in them, because the reducing effect of deactivated yeast is much less aggressive than for some other reducing agents, which will just carry on working and working and working. So it's much more controlled. So we've thrown quite a lot of information at you, so while you just digest that for a little bit, to allow you time to catch your breath, we've got another little survey here which we'd like you to take part in. So this time we're asking you, do you currently use reducing agents in your recipes to combat dough elasticity? So some of you may be already using them, some of them probably don't, or maybe you're not aware whether you do or not. But it'd be very interesting for us to see whether it's a common feature. And I have to say, I'm not surprised at that result. Occasionally, for example, in a change in the flour crop, this is very often when we find that deactivated yeast is at its most useful for an occasional use while the flour crop change is settling down. That happens quite often. But for some people, it's not a problem. So in this final section of our presentation, I'd just like to point out some other uses for deactivated yeast. It can also be used as a raw material in the formulation of an ingredient. And one example is for a mix, where this one, for example, this is a bread mix that we've recently created. And the idea of adding deactivated yeast to this is because it means that whatever flour the baker is using to add to this blend, they're going to get a good, supple, easily shapeable dough in their bakery. It can also be used in the formulation of bread improvers for particular purposes. For example, those that are designed for making laminated doughs or pizza, as I've previously mentioned, and is often used in home baking mixes because there may be home bakers who don't use a machine to develop their doughs. So adding deactivated yeast to a home baking mix makes it easier to mix by hand. So Lesaffre deactivated yeast is available in two versions, as Thibaut has already mentioned. And they're used for different purposes depending on the dough that you're trying to make, or the product that you're trying to make, or the process that you're trying to use. So we can advise you which will be the right one for you to use. And they're available essentially in two strengths. So the level of use depends on the reducing power of the type that you are selecting. So these are both deactivated yeast, but they have different NRP values, which makes them suitable for different purposes. But it's also worth mentioning that dry yeast forms also have a little bit of reducing power. And this is because both instant dry and active dry yeasts contain some dead yeast cells. So, of course, the glutathione in those dead yeast cells is available for its reducing activity in the dough. It's not very much, as you can see. We're only dealing with sort of 10 and 40 ppm, whereas with the deactivated yeast RS190 and RS190 star, we're up in the hundreds. But nevertheless, it can be quite a useful contribution to dough rheology in instances where these kinds of yeast are being used. And if this low level of deactivation, this low level of glutathione isn't sufficient for the purpose necessary, then it can be augmented by the addition of Baker's Bonus RS190 star or RS190. But still very useful, and still useful to know. So, in summary then, Lesaffre is pleased to offer deactivated yeast as a good solution to the problems of dough rheology. And as an ingredient, it answers many of the trends that we measure our products against. So it's easy to use. It's in a powder form that's convenient and easy to use. It's very stable, has a long shelf life. It has a consistent natural reducing power because of the way it's made. It can be used to reduce mixing time, which increases productivity. And of course, the reduced mixing time, as we mentioned, also helps to preserve the natural aromas of the flour because we get a reduction in dough oxidation due to the reduced mixing time. So that can increase the flavour of the final product. It's clean label, which is quite important to our consumers that we know. And because of our reduced mixing time, we potentially can get less energy consumption for our dough making. It's suitable for kosher and halal diets, and it's very useful to solve many common dough processing issues. So just before we close our presentation with our questions and answers, and don't forget you have a chance to ask some questions, so don't forget to add those into the chat bar at the side of your screen. But just before we get to that, I have one more survey for you to have a look at. And this time we are interested to know your opinion about what do you think is the most useful property of deactivated yeast. Is it clean label? Is it the mixing time reduction? Is it improved processing or the improved product quality? I'll give you a minute or two to vote. So we have some very interesting results here. Improved dough processing, which is great because if we can improve our dough processing, we're going to improve our product quality. So that's great to know. So that's wonderful. Thank you very much indeed for joining in with our surveys. And we have a little time to answer some of your questions. And while I give you just a minute or two to think about what you might like to ask, Thibaut, I'd just like to ask a question of you. If you don't mind, just while we've got a minute or two. Can you give us an example of where you might have used deactivated yeast in a particular instance where you've made a real difference to the producer of whatever it is that's being produced?
Yes. Well, for instance, I can remember using deactivated yeast on a fully automated line, a Mecaterm line. Producing baguette bread, and that particular case, the dough pieces were going out of the automatic shaping process, but they were really too short, and they were going on the baguette tray too short. And heading, I think it was RS 190, not the star one. This was RS 190, and usually when you start using that product, you will go with the medium dosage, which is 15 or 15%, 0.15%, and it improves greatly the size of the dough pieces that were going out of the shaping process and that were about to enter the proofing box. Okay, this example, and I also used deactivated yeast on some croissant line to reduce the dough temperature. The dough temperature is critical for croissant production to make sure that the butter doesn't melt. So we try to get a really low dough temperature. So this can help a lot with the dough temperature and also with the shaping of the croissant, reduce the stress.
That's very useful. Thank you very much indeed. Well, we do have some questions. So starting from the top here. This is an interesting one. If a baker is using a dough conditioner, will the ascorbic acid in the dough conditioner reduce the effectiveness of the glutathione from the deactivated yeast? On to you, Thibaut.
It's a good question because, in fact, that it's clear that when you see the effect of ascorbic acid and deactivated yeast effect, they seems like opposite. So you might think, okay, let's instead of adding reducing agents, let's take
out the ascorbic acid.
Yeah, take out the ascorbic acid, reduce the ascorbic acid. but it doesn't have the same effect. In fact, we have many bread improver formulas here in Lesaffre with a combination of ascorbic acid and deactivated yeast. I think the chemical reason, I'm not 100% sure, but the physical or chemical reason is that it doesn't act at the same time during the process. Okay, the ascorbic acid will act during the very first step of the mixing, and maybe the deactivated yeast lasts a bit longer, or I'm not sure exactly. But the reality is that of using reducing agent and deactivated yeast is that it can work perfectly in combination of both deactivated yeast and ascorbic acid. If you read ascorbic acid, you will get less volume and a very fragile dough, but you won't get all the benefits
good consistency
in combination.
Yes, that's my understanding. They do actually work synergistically together. They don't work against each other. I think it's the way they act on the different bonds in the gluten network. So they actually
it's surprising, but it works like that.
They are complementary, yes, rather than contradictory. That's very good. Thank you. We've had a question from somebody who's sadly missed the start. Will the show be made available later? Yes, it will. You can see on this slide here is the link to the YouTube channel that has all of our webinars on there. So our sourdough webinar and our bread improvers webinar is on there. And you will get the answer to that question, actually, about the synergistic effect of deactivated yeast and ascorbic acid on the bread improvers webinar. So have a look at that one. So this is the link. So I will leave that there so you have a chance to have a look at it. But I understand also if you go to YouTube and you search for the Lesaffre channel, it will also come up there. So there we are. Here's a good question. Does deactivated yeast increase sidewall collapse in tin bread during cooling? And does deactivated yeast in any way change the crumb colour of white bread? Well, I can answer both of those questions. Second one first, there is no change to crumb colour of white bread using deactivated yeast, except I will qualify that answer by saying because the deactivated yeast reduces the development time of the dough in the mixer, you've got a reduced oxidation there, and the reduced oxidation means that you will end up with a creamier colour crumb rather than a bright white coloured crumb. But that's a kind of side effect, if you like, of using the deactivated yeast. The deactivated yeast itself doesn't add any colour to the crumb, but it does change it can change the colour of the crumb due to the change in the mixing time of the dough in the mixer. And then as far as the sidewall collapse question is concerned, if the deactivated yeast is used at the right level, then no, it will not cause sidewall collapse. If it's used in excess, it can be a problem. But by the time you should see the excess in the way the dough handles on the line, so before you actually get to the product going into a tin and then being baked, you would see that there's going to be an issue with your dough anyway. So the deactivated yeast itself is used at very, very low levels, as you've seen, and you would only use as much as you need in order to get the effect of the better dough condition. As far as sidewall collapse is concerned, you would need to use an awful lot of deactivated yeast to cause that problem. So that sidewall collapse is much more likely to be a different problem other than using deactivated yeast. So that's the answer to that question. We have a question here. Somebody is asking, what is the reducing power of SAF Instant Gold yeast?
I don't have it with me.
I'm not sure that we actually measure it.
It has a greater reducing power than a fresh compressed yeast, of course. In some countries, some bakers use dry yeast for this property. In summer, and you can use this deactivated dry yeast for this.
Yeah.
Here you have it.
I've gone back to the table.
Yeah, instant
should
red.
be
Yes, so
around
it
there.
should be similar to SAF instant red.
Yeah.
The
It'll be
gold
about,
should
it'll be
should
very
be
low.
similar.
There'll be a little bit, but it will be very low. So
Yeah,
just
slow.
yeah. Okay. So just come back to there so you can check the right. A question here. Does adding deactivated yeast help the final product flavour and aroma in a no-time dough? Again, a little bit, I think, would be the answer to that, because as we've mentioned before, we've got this reduction in mixing time. Would you agree with that, Thibaut? There'll be some increase in flavour simply because
there might be some effect due to the reduction of the
yeast oxidation
the oxidation of the dough, but depending of the kind of bread that you will produce and the amount of mixing that you will provide, the difference might be or not noticed.
Yeah.
You know.
Yeah. And the other thing I would like also to add to that, and I hope you'll agree with this, Thibaut, is that you might get an increase in flavour simply because you will get a different crust characteristic. So the effect of the deactivated yeast on the way the crust behaves in the baking, you are likely to get more flavour from the crust, simply because you've been using deactivated yeast. So you'll get a different flavor profile coming from the crust. So that would happen in a no-time dough as well.
Might happen, yes. This have really those effects will they are not the effect on the taste of the crust or the crumb are indirect effect of
indirect use.
So it should be easier and on the line. I mean,
I think what we're making is that the use of deactivated yeast, because it changes the way the dough behaves, all of these other effects are secondary. I mean, it's because we got a better quality dough and a better proofing and baking and all the rest of it, because the dough is in a better condition, then everything else is improved as a result of that. So the deactivated yeast in and of itself won't add flavour, but because the dough is in a better condition and we're getting a better baking profile and all the rest of it, that is what's going to give you the improvement.
Yeah.
Okay. Another question here about wholesalers and pack sizes. So I would like to refer you, please, to one of our contacts here. If you'd like to contact Roy or Lee or Martin or David, they would be able to, or indeed Andy at the bottom there, they will be able to give you that information. Okay. A couple of other questions. We've got time. Yes, we've got time for maybe one more. I've got several here actually. Which one? Is the NRP value written on the label of the product? It is not, as far as I'm aware. So that's a quick answer to that. Would the use of deactivated yeast in buns increase the risk of them wrinkling after they're cooled? Well, I think that's a similar answer to the one I made about the sidewall collapse. If it's used in excess, then yes, I think it probably would, but it used at the levels it's needed at just to improve the condition of the dough while it's being processed, it shouldn't be a problem. That should not be a problem.
Yeah, using the right amount, it's a commonly used product by hamburger buns producers.
Yeah.
So it shouldn't be any issue.
Okay. And one other question here. Oh, this is a quick one. What's the shelf life of the product? I think it's 18 months, isn't it?
18 months.
18 months, yeah. So there we are. That's a quick one. Do we have time for any more questions? I'm asking Gulton, because I'm not sure how long we've got. We've just hit the hour. No, we're up. Time's up. So thank you very much indeed for all of your questions. And any that we haven't had a chance to answer, or if you have any further questions to answer, then please let us know. and we will answer you by email. So just to let you know that we have another webinar coming up on the 25th of February of next year, and this one is all about tasting. So we're going to have a live sensory panel on this one, so watch out in your inboxes for registration notifications for that. That should be an interesting one. Don't forget that you can revisit this webinar and our two previous presentations on the YouTube channel. Thank you to Thibaut for your assistance today and for your contribution to this presentation. It's been lovely to have you. Nice to see you, keeping well. Thank you again to Galton for putting it all together, which I'm very grateful for. And finally, nothing remains for me to say other than on behalf of the whole Lesaffre UK and Ireland, and indeed the Lesaffre Group, we wish you a very happy Christmas and a happy and healthy and peaceful new year. And we look forward to seeing you on the 25th of February. Thank you all very much for attending, and we'll see you soon. Bye-bye for now.
Thank you very much. Happy Christmas.